Okay. So please write down the problem. Please write down the problem according to relative to entropy. Relative to entropy, that is problem. Okay. 12 meter cube of air. 12 meter cube of air. 12 meter cube of air. Please write down. It is 12 meter cube of air is heated reversibly. Is heated reversibly. നെറ്റ്വർക്ക് ഒന്നും ഇഷ്യൂ ഇങ്ങനെ ഒന്ന് വിളിക്കണം കേട്ടോ വാട്സപ്പിൽ. ഈസ് ഹീറ്റഡ് റിവേഴ്സിബിളി at a constant pressure. At a constant pressure. From 300 Kelvin. From 300 Kelvin to 600 Kelvin. To 600 Kelvin. Okay. And is then cooled. And is then cooled reversibly. So is cooled reversibly. Heated and cooled reversibly at a constant volume. Constant volume. Back to initial temperature. Back to initial temperature. Back to initial temperature. If the initial pressure is 1 bar, if the initial pressure is 1 bar, is 1 bar, calculate first one, net heat flow, the net heat flow. Second one, overall change in entropy. Overall change in entropy. And also represent the process in TS diagram. Represent the process in TS diagram. Yesterday I told that question will be asked in such a manner that after finding the calculating all the values, you want to represent the particular process, not values, represent the process in a particular TS diagram. So you can also draw the diagram initially also. You do not want to find out the value to draw the graph. So the graph is not depending upon the value you want finding. The value is simply from the question you can draw a TS diagram itself. Okay, TS diagram. So we can initially draw a TS diagram. TS diagram you must know the figures of the particular process. Constant pressure process figure is like that, like this figure. For constant volume process, figure is like this. And for adiabatic process, for adiabatic isothermal process, figure is like horizontal line. Adiabatic process, particular line is vertical line. Okay, and polytropic process like in a C curve. Okay, so you must know the exactly the particular that slope of the graph. So you can draw the TS diagram initially itself. Okay, so we can draw the particular graph initially. So what is the question? 12 meter cube of air, the volume, the given data. First round the given data. Volume. 12 meter cube of air is heated. So V1, first volume equal to 12 meter cube. Is heated reversibly at a constant pressure. So constant pressure on from 1 to 2. Okay. So initially a process happening to 1 to 2, that is heating. So at a constant pressure. So therefore P1 equal to P2. It is given if the initial pressure is 1 bar. So P1 equal to P2 equal to 1 bar equal to 1 into 10 raised to 5 Pascal or Newton per meter square. Right? It is given data. So from 300 Kelvin to 600 Kelvin. So T1 and T2 is given. T1 equal to 300 Kelvin. T2 equal to 600 Kelvin. Okay. Cooled by reversible at a constant volume. So first process initially it is a reversible process. A forward process, the particular process is happening initially as a constant pressure process. Thereafter constant volume process happening, heating and cooling. Okay. So we can draw the TS diagram like that. We can draw the TS diagram. We store TS diagram. So it is very important diagram. You want to draw a particular diagram in the center of your notebook. I'm very importance it is very important diagram. That is TS diagram, temperature, entropy diagram. Okay. So what is the figure? What was the figure? So some temperature is not happening from 0 to 0 temperature. Temperature is from 300 Kelvin to 600 Kelvin. So it is not at 0. It is 0 value. And entropy 0 value or temperature 0 value. It is a particular 0 value. So temperature is starting at particular 300 Kelvin. So we can mark a 300 Kelvin here. 300 Kelvin to 600 Kelvin, right? Temperature is from 300 Kelvin to 600 Kelvin is given. And there is a process happening here. 300 Kelvin to 600 Kelvin. So mark a line 300 Kelvin, 600 Kelvin. And at a particular, it is from a 12 meter cube of air is heated reversibly at a constant pressure. Heated, particular heating process happening here is 1 to 2. Take a particular initially entropy 0 initially, so we can take step first constant volume process slope from 300 Kelvin to 600 Kelvin. The left figure constant volume, the constant pressure at 1 to 2, 1 to 2. Constant pressure addition, heating process from 300 Kelvin to 600 Kelvin. Constant pressure process is the slope of the diagram. Constant pressure process. So thereafter, and then it is cooled reversibly. At a constant volume. Heating mode cooling heating process is happening from 1 to 2. So then cooling from back to initial temperature. That means back to initial temperature, constant pressure. So constant pressure in the constant volume. So 1, 2, and next 3, third initial temperature, which is constant pressure process. That is pressure equal to constant, which is constant volume process. Volume equal to constant. This is a simple TS diagram. This is the DS diagram you want to draw for this question. Okay, so you don't want to know about the values of the particular 1 to 2 or T to 3, nothing about the value. But for a given from the given data, or you can draw the particular figure at last. Okay, so initially this is a particular figure of the particular question. That is from initial portion a heating process happening from 300 Kelvin to 600 Kelvin. The graph plot of the constant pressure line is a particular curve line like this, and then it is cooled by constant volume. That is the direction is here. This direction is reverse. Cooled a constant volume to back to initial temperature. So this is the TS diagram for this process. Okay, then we can write a particular question, that is given data. So it is given as the particular gas is air on one country. This is not a methane, those are carbon dioxide. It is given as air. So for if the value of the particular data are not given, we can assume the value of the particular constant value, Cp value, R value, gamma value, or F of air. We can assume we can take the standard value for air. For if the value is not given, we can assume the particular value as for air gamma equal to 1.4. You know that for air gamma equal to 1.4. This is a very important term. For air gamma equal to 1.4. And R value equal to 0.287. R value equal to capital R constant 0.287 kilojoule per kilogram Kelvin. Cp value is 1.005 kilojoule per kilogram, which is a very standard value of air. If that value is not given, we can assume it. Okay, so first question is to find net heat flow. Right? Net heat flow. So for net heat flow, the Q value heat plus the constant volume plus heat. So total heat flow is the initial first constant pressure process heat flow plus constant volume process heat flow. Total heat flow is the addition of the heat flow of the both process, constant pressure process and constant volume process. So Q is the Q1 plus Q2. Total Q1 plus Q2. That is Q at a constant pressure plus Q at a constant volume. Right? So what is the Q at a constant pressure? Give another Q equal to mCp delta T. mCp delta T. That is here delta T means from a high temperature low temperature, that is 600 to 300. That is mCp T2 minus T1. Final temperature minus initial temperature. Final temperature minus initial temperature. What is called as temperature delta T. So Q equal to mCp delta T for constant pressure process Q1, and Q2 equal to mCv delta T, that is final temperature minus initial temperature. Here final temperature is 300 Kelvin, initial temperature is 600 Kelvin for a second process Q to 3, right? Q to 3, that is T3 minus T2, right? This is the Q1 and Q2. mCp T2 minus T1, initial temperature, final temperature minus initial temperature, that is delta T, T2 minus T1. and T3 is given as next MCV delta T means final temperature is 300, initial temperature is 600. T3 minus T2, Q1 and Q2. So here we don't know the value of CP here. We don't know the value of CP here, and we don't know the value of CB here, and we don't know the value of T3 here, right? T3 is not given, CP, CV is not given, and also M is not given, mass is not given. Only volume is given, not mass is given, right? So we want to find the value of mass, CP value, CV value, and T3 value. So from figure it is clear that T1 equal to T3, right? T1 is the particular 300 Kelvin, and thereafter process happened to 2, and initial process back to initial process temperature as T3. So here T1 and T3 is a 300 Kelvin itself. Okay. So T1 equal to T3. From the figure, T1 equal to T3. So we can substitute T3 as T1. അവിടെ 300 നമുക്ക് കൊടുക്കാം, right? T3. So what is the value of M minus CPCB? So to find M, we know that for a perfect gas, PV equal to MRT, right? PV equal to MRT. From here we can find the value of M. So we can take first value, initial value as P1 V1 equal to MRT1. P1 V1 equal to MRT1, and we can find the value of M. So the R value is not given, so we can assume the value of air, standard values of air. Please write down the right side standard values of air. Gamma equal to 1.4, R equal to 0.287 kilojoule per kilogram Kelvin, and Cp value equal to 1.005 kilojoule per kilogram Kelvin. The standard value of air. If not given, we can assume it. Okay. If not given, we can assume it. So from here, making P2 V2 equal to MRT2 GM, right? So either we can find the value by using the initial value or final value. So here V1 is given, initial volume is given. So V2 is not given. So we are taking the initial condition to find the value of M. That is M equal to P1 V1 by RT1. P1 V1 by RT1. P1 is given, V1 is given, R is given, and T1 is given. Right? P1 is given, it is 1 into 10 raised to 5 is P1, into V1 is given as 1.2, divided by R is given as 0.287. That is volume is given in 12 meter cube, not kilogram per meter cube. Okay. So here 0.287 is a standard value in kilojoule per kilogram Kelvin, right? Value is given in kilojoule per kilogram Kelvin ആണ് തന്നിട്ടുള്ളത് അല്ലേ? Kilojoule per kilogram Kelvin ആണ്. So we want to convert the particular value into kilogram 10 raised to 3. Because temperature is given in Kelvin. And pressure is also taken in bar. Pressure convert ചെയ്തു. And whether we are using pressure in bar, we can use 0.287 values. We have converted the value in SI unit. SI unit in the Pascal unit, Newton per meter square unit. We have converted the pressure value. Initially, we convert the pressure value 1 into 10 to 5 ആക്കി മാറ്റി. Temperature is given in Kelvin value over in SI unit. So we can convert the 0.287 R value in SI unit, that is kilogram add ചെയ്യണം. 10⁻³ kilogram ആയതുകൊണ്ട്. And T1. Sorry. T1 is given as 300 Kelvin, right? 300 Kelvin. And ചെയ്താൽ നമുക്ക് കിലോഗ്രാമിൽ വാല്യൂ കിട്ടും. For calculating, you will get the value of M as 1.394 kilogram. 1.394 kilogram and value. Okay. So after finding the value, M is constant for both Q equal to MCP delta TL, MC delta TL. M is constant value. So CV value is given. So you can find the value of Q1 and Q2. So first Q2 CV value is given. CP value is given. So we can find the values Q1, that is constant pressure process Q value, Q1. MCP T2 minus T1. MCP T2 minus T1. That is M is given as 1.394 into Cp value is given 1.005. 1.005. അങ്ങനെ ചെയ്യാം. Okay, അങ്ങനെ ചെയ്യാം. There is another value. There is another method. There is another method. There is another method to find a value. ഇങ്ങനെ ചെയ്യണ്ട. We know that Q equal to Q1 plus Q2. Q equal to Q1 plus Q2. So we can directly substitute the value for Q1 Q2. That is Q equal to MCP T2 minus T1 plus MCV T3 minus T2. Right? T3 minus T2. This is the equation. Q equal to MCV 30. Q1 plus Q2. This is the equation. So from here we know that T3 equal to T1. T3 equal to T1. So we can write MCP T2 minus T1 plus MCV T1 minus T2. T1 minus T2. So we can, there are M and T2 minus T1 here and M and T1 minus T2 here. Common ആയിട്ട് പുറത്തെടുക്കണമെങ്കിൽ രണ്ട് ഒരുപോലെ ആയിരിക്കണം. Common ആയിട്ട് പുറത്തെടുക്കണമെങ്കിൽ ഒരുപോലെ ആയിരിക്കണം. So here MCV T1 minus T2 is there. So to get T2 minus T1 ആക്കണം എന്ത് ചെയ്യണം? To convert the particular value in T2 minus T1 ആക്കണം എന്ത് ചെയ്താൽ മതി? ഈ സൈൻ മാറ്റി കൊടുത്താൽ മതി അല്ലേ? നെഗറ്റീവ് സൈൻ കൊടുത്തു കഴിഞ്ഞാൽ we can convert the value into, we can rearrange the value. ചെയ്തൂടെ? MCP T2 minus T1 minus MCV T2 minus T1. So you have converted the value T1 minus T2 T2 minus T1 ആക്കി and put the value as negative. By changing the value, we can rearrange the particular value. അറിയാലോ? And here M and T2 minus T1 is here. M and T2 minus T1 is here. So we can together take that value outside. M minus T2 minus T1. And the remaining value is Cp minus Cv. Like Cp minus Cv. M into T2 minus T1 പുറത്തെടുത്തു, and the remaining equation is Cp minus Cv. What is Cp minus Cv? What is Cp minus Cv? Anyone? What is Cp minus Cv? ആരെങ്കിലും പറയടാ. What is Cp minus Cv? What is Cp minus Cv? R value. Okay. Cp minus Cv equal to R. Cp minus Cv equal to R. So we can substitute for T2 minus Tv. M into T2 minus T1 into R. So put the value of M here, T2 here, T1 here, R in here to get the total heat value. Okay. M is given as 1.394. T2 is given as 600 Kelvin. T1 is given as 300 Kelvin. And R value is given as 0.287. 0.287. നമുക്ക് kilojoules വരും കിട്ടും. 0.287. We will get the value in kilojoule. Either we will get the value in joule. Here the value will be given in kilojoule itself. കുഴപ്പമില്ല. 1.394 in kilogram. 600 in Kelvin. Given 0.287. By taking the value 0.287, we will get the value in kilojoule. Kilojoule. 120. Value will be 120. 120 kilojoule. This is the heat transfer value or total heat value for the process. If there are two processes or either there will be a three process, we want to add the whole heat transfer rate of 1 plus 2 plus 3. Okay. So we want to adopt a particular equation for finding the heat transfer value in the case of constant pressure process, constant volume process. If the question is asking that, first initially we are heating the particular gas air into a constant pressure process. And then cooled by an adiabatic process. Cooled by an adiabatic process. So you want to find you want to give the value of a particular equation, Q1 as MCP delta T and Q2 as for adiabatic process heat transfer value or Q value. Q equal to W. Q equal to 0. Total Q equal to 0. Then you want to add the work done value. That is MR T2 minus T1 by gamma minus 1 adiabatic equation. ഓർമ്മയാണ് കഴിഞ്ഞ മോഡലിൽ പഠിച്ചത്. So this is heat transfer value. So next, second question is overall change in entropy, right? Overall change in entropy. Solution question le? There are two processes, constant pressure process and constant volume process. To find the net work done or net heat flow, you want to add the heat flow of the initial process and final process. Two processes. So we had done. So overall change in entropy is second question. Overall change in entropy. So overall change in entropy will be same like this heat transfer also. Same for heat transfer, that is overall heat transfer S2 minus S1 or delta S equal to delta minus S2 minus S1 for first process plus S2 minus S1 for second process. Okay, S2 minus S1 for first plus S2 minus S1. S2 minus S1 alla, S2 minus S1 for first process and S3 minus S2 for second. Particular delta S. Total value will be change in entropy of first process to change in entropy of second process. And change in entropy of first process 1 to 2. 1 to 2 plus 2 to 3. 1 to 2 plus 2 to 3. Okay. So for the constant pressure process equation, you know the equation for a constant pressure process, change in entropy for constant pressure process, write the equation. And you also know the constant volume process equation, change in entropy, put the value, add the value, and total find the net overall change in entropy. So overall change will be first process, that is change in entropy for 1 to 2. Process 1 to 2. Process 1 to 2 is S2 minus S1 equal to constant pressure process. Like constant pressure process equation is mCp log T2 by T1. Right? Yesterday we had wrote the equation. Where constant pressure process mCp log T2 by T1. Here we are not added the particular equation as m added because we are taking, for the assumption, we are taking m equal to 1. We are considering m equal to 1 kilogram. M equal to 1 kilogram. So taken m is unity, we don't taken the particular m value. So here there is the process m value. Here there is m value. So you want to take the particular m value, m into Cp log T2 by T1. So m is given, Cp value is given, log T2 is given, T1 is given. So we can directly find the value for the first process. 1.394 is the m value. Cp is 1.005. 1005 log T2 by T1, log 600 by 300. That is log 2. Log 2. So log 2. You will get the value 0.9711 kilojoule per Kelvin. Okay. And a value is nothing to calculate. mCp log T2 by T1. mCp log T2 by T1. Okay. First case. So change in entropy for second case. Change in entropy for process 3 to 2. 2 to 3. Sorry, 2 to 3. What is the question? Constant volume process. Like constant volume process. S2 minus S1 equal to mCv log T3 by T2. Final temperature by initial temperature. Final temperature by initial temperature T3 by T2. T3 by T2. So Cv value is not given, right? Cv value is not given. So we know that Cp minus Cv equal to R. Cp minus Cv equal to R. So Cv equal to Cp minus R. Right? Cv equal to Cp minus R. So substitute Cv as Cp minus R. That is m into Cp minus R log T3 by T2. T3 means T1 itself. Right? T3 means that 300 by 600. 300 by 600. Cp value is given as 1.005. R value 0.287. M value 1.394. And log T3. T3 means 300. T2 means 600. The value will be The value is a negative value. The value is a negative value. Using a calculator, find the value. That value is a negative value. Negative 0.6938 kilojoule per Kelvin. Okay. So total change in entropy. So overall change in entropy will be S2 minus S1 equal to overall change in entropy equal to S2 minus S1 plus S3 minus S2. Both. That is 0.9711 plus minus 0.16. That is minus 0.6938. The value will be 0.2833 kilojoule per Kelvin. Simply we can calculate the whole value. Only you want to know the equation of the particular Q value, heat transfer rate value, and that change in entropy equation value, change in entropy equation. So by know the value of T3, T2, or the particular mass value, pressure, temperature, etc. value, you can directly calculate the value by using the simple equations. By using the simple equations for constant pressure versus constant volume process, constant temperature process, etc., etc., etc. Just substitute the equation. Just you want to know the equation, just study the particular equation only and substitute the equation, the values in equation, and just calculate the value. If there are two processes, if you want to find the net change in entropy, you want to add the change in entropy for each process, and you want to find the heat transfer process also. You want to find individually. You want to find the values of heat transfer for the every process and just add the particular value. Okay, for change in entropy and change in heat transfer rate, you can find. This is a particular application of the entropy process. Here we have completed the equation for we have done a problem using constant pressure process and constant volume process, right? Constant pressure process and constant volume process. We had done a particular we had done a problem. Okay, so what if the process asked in a polytropic or adiabatic process? Polytropic or adiabatic process. നിങ്ങൾ കോൺസ്റ്റന്റ് പ്രഷർ പ്രോസസിനും കോൺസ്റ്റന്റ് വോളിയം പ്രോസസിനും ഒരു പ്രോബ്ലം പഠിച്ചു. അപ്പോൾ ഈ മേഖല എന്ത് ചോദ്യമാണ് നിങ്ങൾക്ക് എഴുതാൻ പറ്റും ഈ ഇക്വേഷൻ യൂസ് ചെയ്തിട്ട്, അല്ലേ? So how we can solve a problem if the question is asked a polytropic or adiabatic? Polytropic ഉം adiabatic ഉം എന്ന പ്രോബ്ലത്തിൽ എങ്ങനെ ചെയ്യും? So we can do a particular problem in the case of polytropic or adiabatic also. ഒരു question ഉള്ള that is, please read the question. 5 meter cube of air, 5 meter cube of air at 2 bar pressure, at 2 bar, 5 meter cube of air at 2 bar, 27 degrees Celsius, 27 degrees Celsius is compressed up to 6 bar pressure, 6 bar pressure. Following equation, following PV raised to 1.3, PV raised to 1.3 equal to constant. PV raised to 1.3 equal to constant. It is subsequently expanded. It is subsequently expanded adiabatically. So first process is polytropic process, second process is adiabatic process. Means okay, adiabatically to 2 bar. Considering the two processes to be reversible, considering two processes as reversible, determine the net work done, not change in entropy. Okay, determine the net work done. Okay, also plot process on TS diagram. Okay, the question is 5 meter cube of air, that is volume, initial volume, pressure is 2 bar, initial temperature 25, 27 degrees to 6 bar pressure, following PV ratio 1.3 equal to constant. Okay, compressed. Okay, is subsequently expanded. It is subsequently expanded adiabatically. Next step is adiabatic. Adiabatically to 2 bar. Okay, considering 2 pressure as reversible. Pressure is reversible and the net work. Okay. So എങ്ങനെയാണ് പോയിട്ടൊരു പ്രോസസ് മനസ്സിലാക്കുക? പി വി റേസ് ടു 1.3 ഈക്വൽ ടു കോൺസ്റ്റന്റ് എന്ന് പറഞ്ഞിട്ടുണ്ട്. സോ ഐദർ ഇറ്റ് വിൽ ബി പി വി റേസ് ടു എൻ ഈക്വൽ ടു കോൺസ്റ്റന്റ് ഓർ പി വി റേസ് ടു ഗാമ ഈക്വൽ ടു കോൺസ്റ്റന്റ്. ഇതിൽ ഏതെങ്കിലും ഒന്നായിരിക്കാം. സോ ദ നെക്സ്റ്റ് പ്രോസസ് പ്യൂറായിട്ട് പറഞ്ഞതിന്റെ അടിവരെ പ്രോസസ് ആണെന്ന് സെക്കൻഡ് പ്രോസസ്. സോ ഫസ്റ്റ് പ്രോസസ് പോയിട്രോപ്പിക് ആയിരിക്കും നമുക്ക് ഊഹിക്കാം. പി വി റേസ് ടു 1 എന്ന് പറഞ്ഞത് പി വി റേസ് ടു എൻ വാല്യൂ. പി വി റേസ് ടു എൻ ഈക്വൽ ടു കോൺസ്റ്റന്റ്. വാട്ട് ഇസ് ദ ഇക്വേഷൻ ഫോർ അടിവരി പ്രോസസ്? പി വി റേസ് ടു ഗാമ ഈക്വൽ ടു കോൺസ്റ്റന്റ്. Okay. P raised to n equal to constant is a polytropic process. Okay. So we can draw the particular figure in a TS diagram. Okay. TS diagram. That is TS diagram. Given data. First you want to write the given data, and we can complete the particular equation in next class. Just you want to write the equation and you can draw a particular figure, and we can complete the question next class. So based on the given data is V1 volume is 5 meter cube, right? T1 pressure, initial pressure is 2 bar, that is 2 into 10 raised to 5 Pascal. T1 equal to 27 degrees Celsius is equal to 27 plus 273 equal to 300 Kelvin. T1. Pressure P2 equal to 6 bar. P2 equal to 6 bar. And thereafter, after compressing, that particular process is reaches to adiabatically to another pressure, that is P3 equal to 2 bar. P3 equal to 2 bar. Okay. These are the given data. So you want to find the value of the heat transfer rate, net heat transfer rate. So you want to find the net heat transfer rate of polytropic process plus net heat transfer rate of adiabatic process. Okay. So you can draw a figure, TS diagram here. TS diagram. What is a TS diagram? TS diagram. How we can draw TS diagram? So TS diagram is first initial process is a polytropic process. So for the polytropic process, figure is like this: 1 to 2, 1 to 2. Polytropic means is compressing, expanding ആണെങ്കിൽ ഇങ്ങനെ വരും താഴോട്ടേക്ക്. Is compressing. So you can write the figure is 1 to 2, 1 to 2. And thereafter second process polytropic figure ഇങ്ങനെയാണ് അല്ലേ, 1 to 2. It is compressing, so we can make the arrow from 1 here to higher temperature or higher pressure. We can write the equation is PV raised to n equal to constant. It's a polytropic process. And thereafter it is expanded adiabatically. So what is the figure of adiabatic equation? Take the particular notebook. Adiabatic process equation it is vertical line, and polytropic it is like this. Expanding process 1 to 2 like this. Here compression is taking this, so reverse. And after 2, adiabatic process. Okay. 3. 1, 2, 3. Temperature, initial temperature is given 300 Kelvin. 300 Kelvin. Okay. This is the adiabatic process. PV raised to gamma equal to constant. Here PV raised to n equal to constant. Polytropic process, adiabatic process. This is a simple figure for a given question. So we can compute the net heat transfer rate for the particular question for the next class. Okay.